Hello, I'm Thierry Ranchin. I'm the last regional GEO presenter, and I will present a work in progress in terms of upscaling. The idea of this presentation is to show a science policy interface example at national level for France, and then discuss how to upscale it. To give you some idea about EuroGEO, you are here the list of objectives, but what we should remind is first data-centric approach to a user-centric approach shift. So that's the clear idea of putting the user in the center of our activity. And also the support to the implementation of the Green Deal and also of the GEO engagement priority. Of course, the idea is also to develop EO application and to demonstrate them at the political level and support all the activity in GEO. So the science and policy interface question we had here came from a policy question to the French government, to the French TSO. The question was how to reach carbon neutrality in 2050. So we have a series of scientific questions that are directly coming from this hard question. What climatic data we should use? What are the scenarios for energy consumption, for energy production? And what, at the end of the day, will be the mix that we should set up, combining renewable energy, nuclear power, carbon-free system. This question has several aspects. The technical one, there is need for description of the network at different years and climatic scenario, but in addition to this, also resilient analysis in order to take into account all extreme events that can occur. An economic aspect, of course, about cost for the society and also reindustrialization for each scenarios. An environmental aspect in terms of carbon footprint of all the solution and all the scenarios that had been proposed, and also the material balance, the land use, waste and pollutant volume. And finally, a societal aspect in terms of impact on lifestyle and also scenarios validity condition in terms of mobility, telework, flexibility of usage, etc. In this science policy interface question, the support of EO data is central because of the need of climatic scenario that came out from the meteorological office, the national one, but also from hydrological information, land use, solar radiation, wind information, etc. for all computation of energy mix scenario. Including renewable energy, of course, but all the production, consumption, and also the evolution of the networks. In addition to this, there is a strong need of in-situ data for consumption, for demography, for the current situation and its evolution, and models that can also handle this evolution and describe it. A series of challenges came out from this science and policy interface question. How to pave the way for the use of the results, how to prepare it, how to use open data and open software, which is mandatory now for all the French institutes, but also the adaptation to needs in order to prepare the future of the energy in France, the communication with the end user. At the end of the day, we reach an answer in terms of a series of recommendations for the future of the French energy mix toward carbon neutrality in 2050, and a series of scenarios that can occur toward this carbon neutrality. So this example at the national level can be upscale, of course, and to do so, there is some needs to be filled. And there is currently discussion for this upskilling at the European level. As you see, the study was conducted by the French TSO called RTE. And so the European counterparty of the TSO organization is called INSTOE, so the European network of TSO. And so they will be probably the one that will need this kind of study at the regional level. To support the furniture of data, of course, there will be the need of the support of ECMWF that is able to handle the climatic data at national level, of course, but also at a regional level and even worldwide, because they have a complete model that allow to give data at this level. And this can be accessed through Copernicus services, called the one called C3S, the climatic change services, and the Copernicus climate change services and the Copernicus atmospheric monitoring services, and also the CDS, which is a climate data store that deliver a series of tools in order to compute energy and production in the future according to the different models existing. Of course, we need other geo data sets for generalization at the regional and global level, and that can be issued from, for example, GeoGloves in terms of hydrological information, but many others that can really contribute to this. And at the end of the day, of course, we can use some output coming out from EuroGEO in terms of methodology about specific application in the domain of energy, which are set up, for example, in SHED, but also the assets, the DIAS, or cloud activities that are available. So I would like to thank you for your attention, and if you have any question.